Mr. Abbott here. Last, flip video, last boring science explanation for air masses, fronts, and cyclonic storm systems. This time we'd like to focus on, the major weather maker for our latitudes, which is the Mid Latitude Cyclonic Storm system. We've come up with a silly little mnemonic or way of helping you remember this, and honestly, this is something that we're going to call the TP effect. Okay, this might help you remember what's going on. So when you have a mid-latitude low-pressure cyclonic storm system, this low is usually what, forms our storm systems. In the middle of this, you tend to have a maritime tropical air mass. So you have a maritime tropical air mass between the fronts with a continental polar air mass around the fronts. So you have continental polar air on the top, maritime tropical is sandwiched in the middle. We were teaching this one day and we drew, this classic open low pressure storm system, and a kid looked and said, "Hey, that looks like a TP. Why are you drawing a TP?" We weren't drawing TPs, we were drawing mid-latitude cyclonic storm systems, but the girl thought it looked like a TP, and then she said that helped her remember what was going on. So we went with it. Why is it a TP? Well, it's warm inside the TP, and it's cold outside the TP. All right, I guess it's warm inside and it's cold outside. That works. Then she mentioned that, well, I know in a low pressure system, it's low in and counterclockwise. So if that's a low, I can picture this air moves this way, this air moves this way, the winds are blowing counterclockwise. So if I've got low pressure, I'm going to have cold air moving into warm air. This is going to be a cold front moving this way, and this is going to be a warm front moving that way. So you have low pressure going counterclockwise. So if you have a cold front chasing a warm front. Is that all? No, that's not all. So I know it's warm inside the TP, it's cold outside the TP. If you're looking at the precipitation, where does it rain? Okay, the rain is going to be falling ahead of the warm front. So you have a broader band of gradual precipitation out ahead of the warm front. The rain tends to wrap around the center of your low, where you've got rising air in the middle of your low pressure system, and then you get a short, heavy, brief thunderstorm, higher intensity, but for a shorter time period behind the cold front. So if you're thinking of it as a TP, it's warm inside the TP, and then the precipitation occurs outside the TP. Now, the winds over here would probably be from the northwest, so the winds are going counterclockwise, but the winds on that side are coming from the northwest. Over here, you tend to have southwest winds moving slower, and over here, it's going counterclockwise towards the center of your low, so the winds shift. So you're going to see a counterclockwise circulation when you're looking at the station models around this. Okay, almost always they'll show you this perspective on a weather map, or they really like to put a cross section right through the middle of the TP, or, honestly, meteorologists would call this the warm sector. So I'm going to look at this. I'm going to look at, say, city X, city Y, and city Z. And what we're going to attempt to do is to draw a cross section of that through our mid-latitude cyclonic storm system. So if you take a look at this, see if I can make this work. But you've got your mid-latitude cyclonic storm system. We're going from X to Y to Z, which is right through the warm sector. So if I want to draw this, I'm going to have the Earth's surface. I'm going to have city X, which is in continental polar, city Y, which is in maritime tropical, and city Z, and my Z didn't turn out, so I'll do that. City Z is definitely in my continental polar air mass. It's ahead of my warm front. So I have my cold front with a steep front and cold, dry air pushing into warm, moist air. And then I have a very gentle, gradual warm front. Because the slopes are different, you get different types of clouds and different types of precipitation. So here's my cold front. The warm, moist air rises. Rising air expands and cools. I get brief, heavy thunderstorms here. So my clouds are cumulonimbus clouds. My warm air is moving this way, and my warm air runs up the back of my cold air. So this is going to give you a completely different assemblage of clouds. You get stratus clouds or layered clouds. So you have nimbostratus and then altostratus. And finally, the thin little wispy cirrus clouds are out ahead of a warm front, but you're going to get gradual precipitation. So if you go through the center of your cyclonic storm system, you've got a cold front, and cold fronts tend to be faster, chasing a warm front, and the warm front tends to be slower. So my cold front is faster moving, and my warm front tends to be slower moving. And that's eventually what probably is going to lead to the formation of an occluded system. So if we go to this last little section, here we go again. We have our classic TP. All right, so this might be my low pressure system. All right, today's date is 2/11. We look at our weather map. We see a nice classic low pressure cyclonic system. Okay, you know it's warm inside, so inside the TP is a maritime tropical. I've got a cold front behind and a warm front ahead. Okay, it would be precipitating ahead of this. It would be precipitating slightly at and behind, but that's the center. That's where my low is located. Now, 3 days from now, if we went back to the same weather map, we'd see that the low pressure has moved or tracked along because of the prevailing winds in the jet stream. So my low pressure may move in 3 days 1,000 miles, maybe 1,200 miles, but my low is going to be moving east to west because of the planetary winds. So 3 days from now, what we might predict is the low pressure will have slid from west to east. So that'll be February 14th, Happy Valentine's Day, and you'd see that the location of the storm has moved. The exact line that the storm moves along is called the track of the storm. And if the storm follows a different track, you can get a completely different forecast. So I have the cold front chasing the warm front, and then we have the whole low pressure system moving. When I look here, my cold front and then my warm front are close together right near the center of my low. So the first place where the cold front is able to run into or catch up to your warm front is going to be right near the center of my low. This would be called an open stage or an open low pressure system. But eventually open systems wind up developing into occluded systems. When you look at the occluded stage, my cold front catches the warm front, and my system now might look like this. I still have the maritime tropical trapped inside. I have part of the cold front remains. So this is the cold front. This is what remains of my warm front. Okay, so there's still like the tail end of my cold front, my warm front here, and my TP has been shortened. It's almost like it zips down from the top. Now, along this section is where I would get my occluded front. So your occlusion is occurring right near the center. I actually have continental polar here and continental polar here. The winds would be going counterclockwise and towards the center of my low because it's still a low pressure, but now you've developed that occlusion across the center, right? So eventually you can move from an open stage to an occluded stage. So there you have warm fronts, cold fronts, stationary fronts, occluded fronts. If you look at a weather map, you have to look for where those fronts are, and you have to predict where they are going to move. Okay, you should definitely know that a cold front gives you short and heavy precipitation, whereas your warm front, your precipitation tends to be slow and steady. If you're looking for a cold front, the precipitation is at the front. And if you're looking for a warm front is not only slow and steady precip, but the slow and steady precipitation is ahead of the front line, where this is short and heavy precip, but this is going to be at and behind the front. All right, if we want to look at this model, the rain would be a wider band of precipitation, but gentle ahead of your low. The rain wraps around the low, but you get short, heavy precipitation along your cold front. So the clouds extend much farther ahead of the warm front, but you have nice, heavy thunderstorms at the cold front. In the occluded front, it's raining ahead of the warm front. You get a band of precipitation here, and you get clouds and rain on both sides of your low. Okay. Inside the warm sector, you know that there's not a lot going on, but you do have the approaching cold front. So if you're inside the warm sector, you're, bound to wind up having the cold front hit you eventually. All right. I hope these explanations helped, and that, you have an idea of what you're looking at when you look at a weather map. Take care.